which you spend way too much time on this one. What? Yeah, you're like parts or U substitution. The problem with U substitution is there anything outside for you to cancel with? No. No, you can't go anywhere with it. Sometimes then you might think, oh, is this some weird trig function? Is this some weird like version of tangent? Do I factor out a 4 and divide by 1 and then go crazy? No. What is this? The square root of 4 minus x squared is a circle of radius what? 2, exactly. Goes like this. Yay, exciting. Ooh, right? And you're going from 0 to 2, right? So what do you have right there? It's 1/4 of pi times the radius squared. So it's going to be 1/4 pi. What's the radius? 2 squared. So what is it equal to? Pi. All done. This is a nasty one because, like, if you don't notice that, you literally can't do it. You literally can't do it, right? We've talked about this before. Small modifications can turn something from like a fun integral to, I don't know. You know what I mean? We've seen this before. We've seen this before totally. Absolutely. Okay.
Can you say that again? Like, that was so fast.
Look, you need to recognize that this is this graph. You're integrating from 0 to 2, right? That is 1/4 of the whole circle. What is the area of the circle? Pi r squared. How much of the circle do we have? 1/4 of it. It's 1/4 pi r squared. Oh, 4 pi. Done. But you have to recognize that that's the equation of a circle. That's it. Okay, okay. What happens if you plug something into itself with me? No. This is like, people think that like all these different math classes are totally disjointed. It's like the same stuff comes up over, it's like, I'm going to do it, and 0 equals 0. The universe has ended, and fun fact, New Jersey was the hottest point in the galaxy a couple years ago. So, anyway, that's actually true. No, that's actually a really good snarky way of saying it. I like that. I only use that line. No, they actually turned on like a fusion. No, they turned on a fusion reactor that was like inputting like 10 million watts and outputting like 6 million. So it doesn't really actually do anything good, but it meant that like the heat at the center technically was like the hottest thing in the galaxy for a little while. Pretty cool. Anyway, we're not creating black holes. We're not creating black holes. What do we have to do? We have to integrate something. Yes, we have to integrate something. So what does dy dx equal? C e to the x plus what? Plus 2x. Okay, so does this match? How can we tell if it matches that or not? Does it match that? Sure doesn't look like it, right? Doesn't even look remotely, it doesn't look like it. I mean, we can feel our way through this. This is the, if you have no idea what to do, try working backwards, right? Try working backwards. So do me a favor, take a minute and try working backwards on a few of these and see if it leads you to any sort of conclusion about how you could go forwards on it. What do you end up with? You end up with this, right? But what does y prime plus x squared equal? If you add, so look, y prime is equal to y, the original function plus what? So this is telling you right here that y prime is equal to the original function plus what? X squared. What happens if you add x squared to this? What does it turn into? It turns into y prime. Does everybody see it right there? Look, take the derivative of this. You end up with the same thing. This turns into minus 2x, and this turns into minus what? 2. So to get from here to here, we took the derivative. But what's another way to turn this into this? What's another way to turn this into this? Just add x squared. Is that exactly what the original relationship is? Yes. So is this one e? Yes, it is.
Why doesn't d work?
Oh, why doesn't d work? Take a look at d here. Look, look what happens here. If you do the derivative here, you end up with this, right? Mm-hmm. If you add x squared, look what you have there. It's a minus. You see, if you add, look, sorry, right there. As a curve in the plane is defined parametrically, an equation of the tangent line at t equals 1. How do you find what's the equation of a line? Y minus, what tangent line is m times what? x1, right? So you need to fill in the blanks there. So you need a point and a slope. How do you find the point on this one? How do you find what x1 is? Time is 1, right? 1 cubed plus 1, what is that? 2. What's y1? 1 to the 4th plus 2 times 1 squared, what's that? 3. So we have y minus 3 is equal to m times x minus what? 2. So what do we need now? We need m. M is the slope, but in parametric land, that's going to be dy dt over what? Dx dt when t is equal to what? 1. So what is dy dt? 4t cubed plus what? 4t all over 3t squared plus what? Plus 1, and you're evaluating if t equals 1. So what's that going to be? 8 over what? 4, which is what? 2. So they have y minus 3 is equal to 2 times x minus 2. Are any of those in the right form? Okay, you got to do a little more. Y is equal to 2x minus 4 plus 3. So y is equal to 2x minus what? 1. Is that one of the answers? Yeah, C.
Yeah, I just let my dx and my dy in there.
Ah.
But could you just also just like find those sort of points and then not bother doing the dy dt over dx dt?
Find what?
Like instead of like because if you plug in like 1.
Maybe just draw a picture. When y is 0, what does x equal? When y is 0, what does x equal? Oh, come on. When y is 0, what does x equal? 3, plus or minus 3, yes. When x is 0, what does y equal? Plus or minus what? 2. So you have an ellipse, right? Here it is. Yay. Exciting. Ooh, my ellipse it's not totally bad. Oh, and I'm labeling it wrong. Minus 2 and 2 and minus 3 and 3. Where to where? The y-axis over, right? And then the y-coordinate is the height. So using that point, what could we find? Oh, we could find all this, right? Correct? What's the area of that green triangle equal to? The rectangle, the green rectangle. What's the area of that green rectangle?
X times root 4 minus.
Yeah, x times the square root of what? 4 minus 4x squared over 9. Do you agree with that? So is it asking us for the actual area of the largest rectangle? No, it's asking us for the largest rectangle that can be inscribed, right? What is the area of the largest, oh, it is, sorry. What is the area of the largest rectangle? Sorry. So if that's the green right there, how do you get the whole thing? Multiply it by what? So we have 4x times the square root of 4 minus 4x squared over what? 9. That's the area of that whole rectangle, right? And what's it asking us for? The area of the what? Largest. So what are we going to need to do? And set it equal to? If you're ever lost, that's like literally the most common thing you can do to maybe help you. Take the derivative, set it equal to 0. Guess what? You can do it. Take the derivative, set it equal to 0, and then you're looking for a maximum somewhere between. You know that x has to be between what? Less than 3 and greater than 0, right? Find that for me. Terms in here. I see this, I see that, and this. That's in both places.
But that's a negative.
I understand, but the base is the same. I understand that. But if I factor out, if I pull out a negative 1/2, I think if you factor that, I think it's easiest to factor that out, I think. So this is equal to 0. So,
And then you move this
to the other side.
to the other side.
Oh, does it work?
And then,
So you got this right here?
yeah, and then you multiply by
The same,
there.
and then you end up with 4 times 4 minus 4x squared over 9 is equal to 16x over 9, like this?
Yeah.
Oh, cool. And then what do? You have to distribute and have some fun?
Yeah, so then,
16 minus 16x squared over 9 is equal to 16x over 9, like that?
yeah.
So then, I don't want to do quadratics. 16 times 1 minus x squared over 9 equals x over 9. Is that okay? Am I okay so far?
Yeah.
You can just divide everything by 16, right? I mean, is everybody with me so far? So what do we have here? 9 minus x squared is equal to x. If I simplify that by multiplying by 9. Is that right?
Or by adding. Sorry.
No, so I'm just getting rid of the 16. I'm dividing out the 16.
Yeah.
And then I multiplied everything by 9 to get rid of the denominators, right? So I end up with 0 is equal to x squared plus x minus what? 9? Does that factor nicely?
Well, isn't it x squared minus x?
I just put it on the other side right there, yeah.
But you can do the quadratic.
Yeah, you have to use the quadratic, so you're going to b squared minus 4ac is going to be 1 minus 4 times 1 times negative 9. So you end up with 1 plus 36 is equal to what? 37? Ugh.
Shouldn't we have skipped this problem 10 minutes ago?
Yes. Yes, we should have. Yes, we should have.
Also a really easy way to get.
D and what? E?
Yeah.
Oh, nice.
Okay.
And then you
Excellent.
should just guess.
So, and then guess. Okay. Unfortunately, I don't. No. It's B, right? The thing is, there might be some pre-calculus identity that we're missing that would do this. The thing is, unfortunately, this feels like it could be the way to do it. Unfortunately, the reason it feels that way is you did it correctly. We just have to make sure we clean it up correctly. And then we get 3x squared. And then what do we do with that x? We're not done yet. We're not quite done yet. You have to take, what do you plug in for x? X is equal to 3 over root 2. And then let's just say, okay, the answer is B. So yeah, it's a good one. How do you do this one? Any guesses? Besides from Cade? You just visualize it? Yeah, so what is it telling you here? It's telling you that you have some function, right? And from 1 to 4, this area is what? 6, right? That's what it's telling you for f of x? So what does it mean by f of 5 minus x? What does that mean?
Oh my gosh.
What is it going to do? What? Yeah, you have to be careful. So this is really like negative x plus 5. What does the plus 5 do? I think it's left 5, right? Isn't it left 5?
Yeah.
Correct? And then what does that negative do? Reflect over what? I think it's the y-axis, right? Because it's anything you plug in for like 5 is going to behave like negative 5, like, right? So you go, which one do you do first? Do you go left 5 and then reflect it? Or do you reflect it and then, what do you do first?
Yeah.
Oh, I think you have to
Does
factor
it
out
matter?
the negative.
What do you mean factor out the negative?
Because if
Can you factor out the negative? Is that allowed?
negative parentheses x minus 5, because I feel like the 5 has to be.
Oh, so you're saying like take it like this. So f of like negative parentheses x minus 5,
Yeah.
like this.
Yeah.
So I like that. That's a really good way of looking at it. So what is the x minus 5? So what does this mean? You go right 5 and then reflect it. So you bring this whole thing over and then reflect it. And then you're going from 1 to 4.
Mine is. It doesn't
Look at
change.
this
No,
thing.
reflect it and then 5. Reflect it and then 5.
Reflect it and then 5. Okay, so if we reflect it and then 5 and then run this integral, what's the answer going to be?